Welcome back, everybody. Today we are going to talk about the trig functions of any angle, part 1. We're going to break this down into 3 parts. The first part is going to be on just angles in general, the second on quadrantal angles, and the third are the signs of the 6 trig functions. So welcome to part 1. So let's start by taking these right triangles that we've been talking about and putting them onto the Cartesian coordinate system. Here I have my xy axes. I have a point P which has coordinates xy, and I'm going to draw my line from the origin to P, and I am going to label the angle theta as having its terminal side on the line that connects with P, and its original side on the x-axis. So I have labeled my theta. Now what I can do is I can drop a perpendicular from P directly to the x-axis. And I can label some things here. First of all, the distance here is x, which is the same as the x-coordinate. Do you see that? And then the vertical distance from the x-axis to P is going to be the length y. And we are also going to call the length that goes from the origin to P r. So we have a right triangle, but it is now superimposed on the coordinate system. So let's figure out what our sine, cosine, and tangent for this particular instance is going to be. So we know that sine is opposite over hypotenuse, and that's going to be y over r. All right? Okay, next, let's look at the cosine. Where's the cosine? Well, the cosine is going to be the x length over the r length. And I've checked those off there, so it's going to be x over r. And tangent is going to be y over x. Just like we've been talking about opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, except now we're going to actually use coordinates to define these. So if I want to find the other 3, the reciprocal functions, cosecant is going to be r over y, secant is going to be r over x, and cotangent is going to be x over y. Let's look at an example using real numbers, and we're going to keep this in quadrant 1 again. So I'm going to pick the point 3, 4. And I'm actually going to plot that point 3, 4. And I'm going to show you some steps that you need to follow in order to work this example and the examples that we're going to do from quadrants 2, 3, and 4. First thing is plot the point and draw a line from the origin to that point P, which we've already done here. Next step is to draw a perpendicular line from P to the x-axis. You're always going to draw it to the x-axis, never to the y-axis. So there we have our perpendicular. And then we want to label the lengths of the legs and include direction from the origin. So this is going to be, there's my right angle. The x value is a positive 3, or 3 in the right facing direction. And our y is positive 4. And if we want to find r using the Pythagorean theorem, that's not too hard on this one. We know it's a 3, 4, 5 triangle. Or if you didn't remember that, you could use the Pythagorean theorem to solve for r, which will be 5. That length, that hypotenuse length, will always be positive. It will never be negative. So now, if we want to find the sine of theta, the sine of theta is going to be opposite over hypotenuse, which is 4 over 5. The cosine will be adjacent over hypotenuse, which is 3 over 5, and the tangent will be 4 over 3. Now once we have those, it's not so hard to find the reciprocal functions for the cosecant, which is 5 over 4, the secant, which is 5 over 3, and the cotangent, which is 3 over 4. Pretty simple, huh? Now I want you to notice something. All of these values for sine, cosine, tangent, all of them are positive. In the first quadrant, all of the functions are positive. They all have positive values. So let's see how this plays out for the rest of our three quadrants. We're going to do quadrant 2, quadrant 3, quadrant 4, and we're going to take that same point 3, 5 and just move it around into the different quadrants. So let's draw them like this. And in quadrant 2, the point would be -3, +4. X is negative in the second quadrant and Y is positive. So if I draw my line, and theta now goes from the x-axis all the way over into the second quadrant, and I have marked theta here. I'm going to drop my perpendicular to the x-axis, not to the y-axis, to the x-axis, and I am going to label my values. X is going to be now -3, y will be +4, and of course r is always going to be positive. See that the value of x is negative and the value of y is positive. So now let's take a look at what would our sign be. Well, the sign is going to be 4/5, opposite over hypotenuse. Cosine is now going to be -3/5. So instead of the +3/5 that we had in the first quadrant, cosine has changed to a negative value. And tangent is -4/3. All right? Got that? Okay, let's move on to quartile 3. In quartile 3, the point is going to be at -3, -4. So, once again, same thing as always. We're going to draw our angle, and it goes from the x-axis all the way around into the third quadrant. And now we're going to drop our perpendicular because we're going and label our values, which are now -3 and -4 for x and y, and still +5 for the hypotenuse. So now our sine will be -4/5. Our cosine is -3/5. And our tangent is -4 over -3, but remember a negative over negative is a positive, so it'd be 4/3. And you seeing how the same values except for just changing from positives to negatives and negatives to positives. Okay, let's take a look at what happens in quadrant 4. Let's redraw this. Had a little boo-boo there. Okay, so it's -3, 4. Draw the line. And this is our going back to the x-axis. And this will be +3, -4, and 5. So sine of theta is going to be -4/5. Cosine of theta will be 3/5. And tangent of theta, which I should have written the theta and missed that, is -4/3. So we have the same values, but as you see, as the angles go through the different quadrants, they change their values as far as their positives and negatives. All right, we're going to take just a minute and let it recopy what we just found into something that we can observe a little bit better of what's alike and what's different. And here we go. Okay, so these are the values that we came up with in the first, second, third, and fourth quadrants. So what we want to know is where are the values positive? And we have quartile 1, quartile 2, quartile 3, and quartile 4. Well, if you notice, in quartile 1, everything is positive, sine, cosine, and tangent. In quartile 2, the only thing that's positive is the sine. The cosine and tangent are negative. In quartile 3, the only thing that's positive is the tangent. And in quartile 4, the only thing that's positive is the cosine. Now, this is something that's going to come in real handy here in just a couple of days as we are working through some of these problems, and that's knowing where each one of the functions is positive. If you memorize where it's positive, then you know where it's not positive, it has to be negative. So here's a way that you can remember this. Everything is positive in quartile 1, or quadrant 1, I'm sorry, I'm saying quartile. And just the sine is positive in 2, the tangent in 3, and the cosine in 4. Okay, let's figure out a little way to memorize this or to remember it. If I draw my quadrants, and I start with quadrant 1, that was all, so I'm going to put an A in there. In quadrant 2, just the sine was positive, so I'm going to put an S there. In quadrant 3, the tangent was positive, so I'm going to put a t there. And in quadrant 4, the cosine is positive, so I'm going to put a c there. Here's how you can remember it. All students take calculus. All students take calculus. You see how it goes around the quadrants? All for the first quadrant, students for the second quadrant, take for the third quadrant, calculus for the fourth quadrant. One thing we haven't addressed but makes sense, and that's if the sine is positive, the cosecant is also positive because it's a reciprocal function. So I only talked about sine, cosine, and tangent, but know that every place where the sine is positive, so is the cosecant. Every place that the cosine is positive, so is the secant. Every place the tangent is positive, so is the cotangent. They follow along. So if you memorize just the first three, sine, cosine, tangent, then you can follow along with the others. Okay, let's work on an example here. Let's take point -3, 5, and say that's on the terminal side of angle beta. We want to find the cosecant of theta and the tangent of theta. All right, so let's draw our axes, and let's plot our point, which is at -3, 5. I'm going to draw the line, drop the perpendicular, and do our labels. -3 for the x and +5 for the y. If I use a Pythagorean theorem to find what r is, I find that r is going to be the square root of 34. So I'll put the square root of 34 there. Now the cosecant is going to be the reciprocal of the sine. So if sine is 5 over the square root of 34, then the cosecant is going to be the square root of 34 over 5. Okay, what about the tangent? Well, the tangent is going to be the opposite over adjacent, which is 5 over -3. Notice that the cosecant, like the sine, is positive in the second quadrant, and the tangent is negative, just like what our little chart had told us. Okay, so sine is greater than 0 in quadrant 2. Next video, we want to talk about what about quadrantal angles. Stay tuned.